The session state contains only the master secret key. Only one master secret key.
Do you have an example about the sequential?
Yes, sequential. Yes. Sequential connections. Yes, definitely. If you want to buy, we talked about session state. This is the connection state. Connection state contains these temporary keys and the random sequence. Amazon, same old example. Okay, we talked about. طيب السلام عليكم. بسم الله الرحمن الرحيم. So we start to talk about the different protocols within the TLS standards. So we talked about 4 different protocols. We talked about the handshake protocol, the alert protocol, the heartbeat, the change cipher spec, and the record protocol. So the protocol data unit itself specifies a very important field, اللي هو type. This type really indicates whether this message is part of the change cipher spec, or it's part of the alert protocol, or it's part of the handshake, or it's part of the record protocol, which is the actual tunnel. It's like data. So all these other messages are control messages. This is the only message that contains data inside the tunnel. They have the actual data which is encrypted and authenticated with the padding and everything. So the first protocol is very easy. The first protocol contains only 1 byte, and this byte is just a flag. And by change cipher spec, as we said, first we start with the handshake. The handshake creates the security context اللي احنا قلنا عليه اللي هو الستيت اللي هو السيشن ستيت ماشي. And this session state bag contains all the different algorithms that are used for authentication, for encryption, and everything. And then this change cipher spec is used to say, okay, so I'm going to use, from this session state, I'm going to use one cipher spec to be the current one for this connection. Okay? So it's just a flag to say that now this cipher spec is the current cipher spec that I will use for this particular connection. Okay? So at certain points, بناءً يعني based on the fact that I notice some some alerts or something, I can report these alerts. Based on these alerts, we have 2 types of alerts. We have warnings and we have fatal errors. So the level is either 1 or 0. So 1 is just warning, and by warning we mean that خلاص يعني it's just a warning, but we can continue working. Okay? Fatal error indicates that خلاص, this connection has to be stopped. This connection has to be stopped, and the security or the cipher spec that we are using for this connection has to be changed. So in that case, we have to go back to the handshake, create another cipher spec, and then make this current through the change cipher spec. So this is how it goes, right? So the handshake, of course, contains all the messages that are being exchanged between the client and the server, okay, for authentication and key exchange. يعني ده الأساس for authentication and key exchange. This one has a bunch of messages that we will talk about in details today. Okay, once all of these are finalized, so all the control messages are finalized, and we have a cipher spec that we can use currently for this particular connection. The cipher spec contains all the keys اللي هم الconnection keys اللي احنا اتكلمنا عليهم. Connection keys are اللي هم server write MAC key, okay, client write MAC key, ماشي. the server write key اللي هو used for encryption بقى, not the Mac. The client write key اللي هو again for encryption, and the server IV and the client IV. So those are 6 temporary keys that need to be created, okay? And these keys, by the way, are created from what we call the master key. So the master key is used to derive these 6 keys based on, again, pseudo-random function. Pseudo-random function is it's similar to the key expansion techniques that we have studied as part of DES and AS and stuff like that. So we can, based on the master key and based on some other parameters, we use pseudo-random function to generate like a random sequence. From this random sequence, we can create by the different keys. So
the alert protocol, so I understand why the level has a byte, but you said the alert is either 1 or 0.
Right.
So why does it have a byte also?
The alert?
Yeah.
Yeah, because the warning, what is that warning is about? It's just a code.
Right.
So in that case, it's a code. And of course, 1 byte gives you 256 different codes, which constitutes by what is this warning is all about. So you have 256 warnings and 256 fatal errors that you can have. And these fatal errors and warnings are documented in the standard. So for example, code number 200 is this, code number 201 is this, and so on.
So
the description itself is standardized.
So it's not each level that has its own 256 warnings. 256 warnings based on
right. So the level says this is warning or this is fatal error. Okay. So if it's a warning, okay. So what is that warning is about? Okay. So the alert is just a code, and from this code you can look up the description. So for example, it's similar to عارف في الويب اللي هو 404 page not found. Okay. So when you click and you get 404. So how do you know the description? You look it up. You say, okay, so what is the description corresponding to 404? So you see that the description is page not found. Okay? So that's the exact same thing. But here it's related to security.
The same error can be used for different levels, right? The same warning message can be used for different levels or not?
Yeah, this one is either 1, which is warning, or 2, which is fatal error.
Okay.
That's it. So you have two possible values for the first byte, lower level. Okay? But within each level, you can have 256 different codes or alerts. Okay? So alert itself might indicate a warning or a fatal error. ماشي? So what we need to do or to discuss now is that based on this handshake protocol, how can we find or generate the master key? What are the steps, okay, required to come up with the master key? Because as we said, the handshake is used for authentication and key exchange. Once we have the key exchange, we have a master key which is shared between the client and the server. From the master key and from other fields that we will talk about, we can use pseudo-random function to generate all the 6 keys for one particular connection. For one particular connection. That's why these IVs, okay, these IVs, they get changed dynamically throughout the time, and each connection might have different keys, even throughout the time. Even the same connection might have different keys if the connection lasts for a long time. So all these keys are temporary. Could be used for one single connection, or multiple of these can be used for one single connection. طيب. So the session itself is alive when you go from one page to another. The session is still there. So you are trying to buy certain items, then you group all the items, you select them, you put them in the cart, and so that's a full session. So when you go from one page to another, each click creates a separate connection, right?
I go to another page, this
Yes.
parallel in the same page.
Yes, in the same page. Exactly. تمام كده؟ So discuss now بقى is what is the sequence of messages that we need to exchange as part of the handshake protocol. This is the most complex because the other protocols are very simple. Alert protocol is simple. The change cipher spec is just a flag. The current cipher spec is to be used. That's it. Just a flag. And of course, we have the heartbeat protocol, which is not in this picture. We'll talk about the heartbeat protocol. So again, the change cipher spec protocol, it's the simplest, and it consists of a single message, which consists of a single byte, okay, with a value of 1. The sole purpose of this is just to say that the pending state is currently to be used as the current cipher spec. That's it, okay? The alert protocol, as we said, it conveys طبعا TLS related alerts, because again there is HTTP related alerts. There are session related alerts from HTTP, but these are different. Here we're talking about security related alerts. And each message contains 2 bytes. The first byte is whether a warning or an error. ماشي? 1 is warning and 2 is error. That's it. Warning means that the connection might still continue, but I'm just reporting some warning. Fatal error is like, this connection needs to be stopped immediately because there might be some مثلا replay attack or some breach of the connection somehow. تمام. So if the level is fatal, okay, the current connection gets stopped immediately. But the assumption here is that, remember, as we said before, we have the client and we have the server, right? And we have the session, the HTTP session, okay? Inside this session, we have multiple connections. صح? These connections might be sequential or parallel. ماشي؟ يعني when you click on a link, this link will give you a page. This page contains some graphics and it contains some video and it contains some. So each object inside this page might actually take different connection, different TCP connection, which means that all these connections are to be run in parallel. Okay? So each of these connections, it uses a different cipher spec, a different set of keys. مفهومة دي ولا؟ واضح؟ So each connection uses different keys. All of them are driven from the master key, صح. But each connection has to use different set because these keys are temporary keys and these are connection state. This is not a session state. The only thing which exists in the session state is the master key. How? This is what we said. Again, why we say this? Because the assumption now is that the alert is valid for one particular connection. So if the alert says that there is a fatal error for this connection, then this connection will be cut. This connection will be torn down. But all the parallel connections can still go on. Yeah, this is what this says here. Other connections on the same session may continue. ماشي؟ But no, بص بقى شوف بقى الاسامبشن. But no new connections on the session may be established. مفهوم كامل؟ So these other connections that are running in parallel will finish. The one that contains the alert will be cut immediately. The ones that will come after will not come because there was a security breach. If it's a fatal error, if it's a warning, no problem. But if it's a fatal error, this means that you have to go back to the handshake protocol and you have to re-establish the state, the session state from the beginning re-establish a master key, and then and only then you can continue. Okay? This rarely happens to some people. I got a poor guy from CAS. He said that I'm trying to connect to this particular website, and every time I connect, it says your certificate is invalid, and that's it. And he cannot access this website at all. So somehow when he connected on this website, the website invalidated his certificate, and it does not allow him back to خلاص, this is a fatal error, and it does not allow him to continue anymore on the website. خلاص, he cannot do anything on the website. Okay? But this can be resolved if the website allows you to renew your certificate, because you can really, but يعني, after some time, I mean, he was able back to contact Microsoft support, and through the website, he was able to trigger creating a new certificate, because this has to be done inside Microsoft, inside the operating system. So he has to create a new certificate to be, again, verified by Microsoft as a certificate authority. So when he connects on this website, he uses the new certificate. Once he uses the new certificate, the website will allow him to do this. But in any case, he cannot continue any further because his certificate, for some reason, is invalidated. And that's another thing now, is that the authentication, by the way, can be done in a bunch of different ways. It can be the certificate, the authentication, it can be done using certificates. It can be done using user ID and password. It can be done using a bunch of different things. Okay? Especially on web. That's why sometimes when you click on a link to connect to a different website, sometimes you get in right away. Okay? Sometimes you have a pop-up that says user ID and password. You need to enter user ID and password, because that's a secure domain, and you need to have user ID and password in order to connect to this private domain. So the authentication itself can take a bunch of different methods. And based on that, the key exchange might happen in a different way. So some web servers, they use, for example, Diffie-Hellman. Some web servers, they use RSA مثلا through certificates. Okay? Some web servers, they use user ID and password. Okay? And based on the user ID and password, somehow they generate the key. So there are a bunch of different ways to authenticate yourself. Based on that, the key that's generated might be generated from different methods. So we'll talk about this. You have a question?
Yeah. With regards to level 1 warnings, is it like with replay text? If you get multiple low-level warnings, then you shut things down. Is it the same case here? If you're getting multiple level 1 warnings, non-fatal, would you shut things down and start from scratch?
The standard does not dictate this. The standard itself does not dictate this. So, but the standard differentiates between the warning and the fatal error. But if you get multiple warnings of the same type, مثلا, would you consider this as fatal error or not? The standard does not dictate this. But again, it's up to some of the implementations of TLS that says, okay, so I'm going to interpret multiple warnings as fatal error. I can do that as part of the implementation. But the standard does not say you have to do this. So we'll talk about other examples that, because of the fact that the standard does not dictate this, different implementations may work differently, and that may have actually some consequences. We'll talk about one example about this. So in any case, this is the alert protocol. So we understand now that fatal error means that all the current connection where the alert is reported, it has to be cut immediately. Parallel connections may continue, but future connections may not be established. That's what that means, right? Type. The handshake protocol is the most complicated, because this is the one that is used to exchange and negotiate the authentication and key exchange, and the end result of this should be the master key, a shared master key between the client and the server. Imagine. So the handshake allows the server and the client to authenticate each other ماشي, to negotiate an encryption and MAC algorithms and so on. But the encryption and MAC and IVs and stuff like that, this is part of the connection state, right? And this connection state is driven from the master key. ماشي? نشوف ازاي. The handshake protocol is used before any application data is transmitted. So this is number one. So everything is initiated from the handshake protocol, and we'll see the messages that are used as part of the handshake protocol. The handshake protocol messages have format shown in the following. So these are the different messages. Again, you don't have to memorize all these messages, but you need to understand the different phases of how the handshake is done. يعني we studied in network 1, there was simple connection establishment بتاع TCP, SYN وبتاع. لا, هنا الموضوع is much more complicated. هنا is a little bit more complicated. Okay? Because you have to هي basically again we can everything comes down to the fact that before we exchange a key, we have to authenticate ourselves to each other. Okay? So we expect to have some way of authentication, and we have studied different ways we can do that, especially for web servers and web clients. We can authenticate each other using user ID and password, or we can use certificates to authenticate ourselves to each other, right? These are the most two common methods. Based on that, once we authenticate ourselves, then we have to use some key exchange. Okay? Key exchange could be, we can use, again, RSA, which means that, or Diffie-Hellman. ماشي? These are برضو some common mechanisms that are used for key exchange. Okay? طيب. So these are the messages. We don't have to again memorize the messages. يعني we'll talk about the sequence of these messages. This is what really concerns us. So the handshake happens in 3 phases. Phase 1, phase 2, phase 3. Why did I not mention phase 4? Because phase 4 is part of the change cipher spec protocol. It's not part of the handshake protocol. ماشي? يعني once we have this, what happens here is that now we have a master key. So here we have a master key. Okay, and we'll see that حتى before the master key we have something called pre-master key, and I will talk about this. From the master key here, at this point, we derive the cipher spec. The cipher spec اللي هم server MAC, client MAC, server key, client key, IV. So this is the cipher spec, complete cipher spec. And then here we say, okay, change cipher spec, make this the current one to be used for this particular connection. And then here we start to send data back and forth. So this is part of the change cipher spec. And this is just to send 1 byte to say, okay, make this current. This is to be used by this particular connection. ماشي? And then finished. خلاص. I finished everything. So the entire handshake has been done. And now we have complete cipher spec, which is fresh and current and can be used for data exchange. طيب. So the 3 phases contains what? So the first phase here is just to report, and again, unlike by IPsec, because IPsec, it's a negotiation between 2 routers, ماشي, or a host and a host. Here we're talking about a client and server. These are endpoint applications. These are end applications. ماشي كده? So what we do is that in phase 1 we just report our capabilities. Okay? We just report our capabilities. Our capabilities in terms of the fact that the client tells the server, okay, here are the mechanisms that I can use for authentication. Here are the mechanisms that I can use for key exchange. But it's up to you طبعا to select. Why? Because as we can imagine يعني, client is always the one, احنا قلنا تعريف الكلاينت network one is the one that initiates the communication. صح? A server is like from the name, you request a service from the server, so you should ask me what you want. Okay? But when it comes to the connection, the server is the one that drives how you will connect to the server. Okay? So the server is the controller, is the one that drives the communication. But the client is the one that initiates it. Okay? طيب. So the sequence goes as follows. The client says, okay, here are the capabilities that I have. Okay, so for authentication, I can use certificates. I can use authentication using user ID and password. I can use this, and it reports these methods in the preferred order that it wants. So I can, and it always, most of the time, it uses certificate as the first preferred choice. But if you don't have this, I can provide you with user ID and password. And if you don't have this, I can خلاص يعني خليها حبي و I can connect without user ID and password. So these are the different methods that I. Similarly, in the key exchange, I can use Diffie-Hellman, I can use RSA, I can use elliptic curve. ماشي? I can use these techniques in that order. Okay? So this is what the client sends in the hello. Hello, I have all of this. Which one do you want to use? That's it. ماشي كده؟ So based on this, the server will say, okay, hello, I have this in that order. And then they negotiate and reach that. Okay, so the server says the first one is user ID and password. خلاص يبقى أنا I have to use user ID and password. The server says RSA. خلاص يبقى RSA. خلاص. So here, each one knows which method that will be used for authentication and which method that will be used for key exchange. So طبعا once we say this خلاص يبقى احنا هنا this is the authentication and this is the key exchange basically. That's what this is. So in phase 2 so see بقى هنا authentication happens from the server because the server is the one that drives how the certification is going to go. Okay? So that's why when you say click on a link, it goes to the server and the server says, I need you to enter user ID and password, or I need your certificate. Okay? So that's why the server starts the authentication first. It sends its own certification, and then the server هنا will send, خد بالك, the server will send key exchange. Here, can you guess what's being sent here? For the key exchange, what do we need in terms of what facilitates the key exchange?
Depends on the protocol. So if it's
Assuming مثلا Diffie-Hellman, okay, what do we need?
you need the P and Q.
اللي هم بنسميهم alpha and Q. صح، برافو عليك. So here, for if it's Diffie-Hellman, okay, then we have y equals alpha to the power x mod q. Okay, I can send q, alpha, and y as we said, but this x is private. صح? So as part of the key exchange, I can send alpha, q, and y. Okay, so this is what gets sent here. I did not yet يعني calculate the key, because the key is calculated locally. Okay? And then the server sends a certificate request to force بقى the client to ايه؟ ده اهو انا اديتك كل حاجه اهو. You have everything. Okay, so now you need to authenticate yourself, and you need to use user ID and password. This is what I will tell you. Okay? So now خلاص the server part is done, and here the client will say, okay, خلاص, here is my certificate, so I'm authenticating myself, and here is the key exchange parameters. ماشي? And خلاص, and here the certificate is verified. The certificate verified ده اللي هو for ايه؟ For the certificate that has been sent from the server. Okay, so the client is saying, okay, so I'm verifying your certificate, and here is also my certificate to authenticate myself, and here is the parameters for the key exchange. One thing we also send with the key exchange is another parameter, or another thing, which is a random sequence. Okay, this random sequence, we talked about it in the session state. Why bad? Why we send a random sequence? يبقى احنا we send all the parameters required for key exchange. If it's Diffie-Hellman, it's alpha, q, and y. If it's RSA, it's the public key, things like that. So خلاص, we know how to exchange the key, but we send with it a random sequence. Why? Why? Because what we will exchange, it's not the master key. It's something called pre-master key type. Why? Because if you look back, we said that the master key is of size cam 48 bytes. It's fixed. The master key has to be fixed in terms of size. Okay? So how can we guarantee that the output of the Diffie-Hellman or RSA, okay, will be 48 bytes? Actually, we don't. We don't have to do this. Okay? So based on the method, you generate a pre-master key of any length. مش مشكلة. ماشي؟ مفيش مشكلة. Okay? Maybe the length is 200 bytes, 100 bytes. The length is 30 bytes. Doesn't matter. Okay? And then what we do here is that we say the master key equals what we have after these two steps. What we have is the pre-master key. صح? And we have exchanged server random sequence and client random sequence. As part of the server key exchange and client key exchange, we send the parameters for key exchange, and we send server random sequence and client random sequence. Okay? So from this, we run the pseudo random function, okay, to hash and create one master key. This one is of length 48 bytes. Fixed. Why? Because this pre-master key is for variable size. Variable size based on the method. If it's Diffie-Hellman, it could be of 30 bytes. If it's RSA, it's different. ماشي? So depending on the method, it might have variable size. So from this variable size, we can hash it and create a master key of fixed size, which is 48 bytes. ماشي؟ Using بقى اللي هو الهاشing using بقى HMAC ولا واضح كده؟ So now we have pseudo random function to hash, and then بقى interestingly speaking we have ايه بقى؟ we have now the master key, and then the next step here at this point, what happens is that from the master key and the server random sequence again, and the client random sequence again, and the standard does not, so you can add even مثلا port, server port, random client port, things like that. You can add other fields to it. And again, you run another pseudo random function to generate بقى ايه؟ a data structure in that case. Not just one number. You create a data structure. This data structure is server write MAC, client write MAC, server key, client key, server IV, client IV. اللي هم بقى الكونكشن ستيت. So يبقى احنا we have to do it on 2 steps. Why 2 steps? Because the pre-master key could have variable size. Okay? But احنا the master key has to have fixed size, 48 bytes. So the first step is from the random sequence and the pre-master key, we generate one master key only. And then from the master key and again the random sequence again, we generate all the 6 other keys. طبعا obviously this pseudo random function is different from this. So the standard defines 2.
Doctor, is this after the user signed up, or is this the very first connection? Or this is for between server and
But this is between client and a server.
right.
ماشي? So this is the session state. The session state اللي هو based على الهاندشيك protocol, we have the session state. But then at certain point we have to have a connection state. A connection state is driven from the random sequence and the master key. We can generate multiple connection states. ماشي? So each connection state can be used for one particular connection between the client and server, and the connection has a short term, صح? It's for short term. We can have multiple connections in parallel or sequential, but each connection has to have a different connection state. ماشي كده؟ That's the sequence. So this is what's explained here. So for creation we have 2 steps. So we have 2 steps. We have first the pre-master key by means of the key exchange. The shared master key is of different size. ماشي? So the generation of the cryptographic parameters from the master key happens using the pseudo-random function. And from the pseudo-random function we create by server specs. Multiple server specs for each connection. Require the client write key, client write MAC key, server write MAC key, and as we said, while there is write but there is no read. صح? Because the server write key is the client read key. لأنه هو shared. لأنه هو shared key. It's one key. ماشي? A client write key, a server write key, a client write IV, and server write IV. اللي هم the 6 different keys that we talked about. These parameters are generated from the master key by hashing the master secret into a sequence of a sequence of bytes that gets generated and exchanged between. So the secret part is the master key, which is done using Diffie-Hellman. صح? This part is secret. But the random sequence is to be sent. It's sent, صح? Random sequence is exchanged. Based on the random sequence and the master key, I can generate a bunch of other keys. ماشي؟ تمام. طبعا the heartbeat protocol, as we said, is used for what we said last time. Is used to report to the other side that I'm alive. ماشي? And we said that طبعا heartbeat protocol is used in many contexts, in many fields. In network 2 we taught heartbeat protocol as part of some dynamic routing protocols مثلا. ماشي? So heartbeat protocols are commonly used for if we try to exchange some messages asynchronously. ماشي؟ معناها ايه؟ we're not sending regular messages. طب ما انت ممكن يعني you can stay for 2-3 minutes not sending me anything. افضل انا بقى قاعد متعلق يعني there has to be some يعني wait time after which I assume that you are not there. خلاص. Okay? So this happens in different contexts. This happens in different contexts. Dynamic routing protocols where طبعا routers they exchange some update messages and stuff like that. They use some kind of heartbeat protocols. But here in the context of security, we need heartbeat protocol. Why? Because again, if you do not keep the session alive, chances are there are certain firewalls that will invalidate the session. ماشي? In which case, after waiting for a certain period of time, you will be kicked out and you have to do the entire sequence again. And that's what happens if you try مثلا to connect على طلبات مثلا from outside the university, you get kicked out. يعني you start to write the form, you start to fill, and then you click, it kicks you out and you have to repeat the whole thing. You enter, and sometimes it's very frustrating. Okay? So the system analysts, ماشي, they need to configure carefully this heartbeat protocol to give enough chance based on the interaction with the website. So if you are trying to fill a form of مثلا 20 different fields, you should not expect I will fill this form in 5 seconds يعني. ماشي? But in fact, if you do not configure heartbeat protocol, chances are the firewall will invalidate this session, and after 5 seconds it will kick me out. And every time you fill the form, you get kicked out, and so on. It happened to me a lot. So the heartbeat protocol is used for that particular purpose, is to try to keep the session valid, even if there is no interaction between the user and the website. Okay? So you click on the link to check out in Amazon, then you have to fill all your credit card. But even before filling your credit card information and stuff like that, you start to think about, why did I, what am I getting myself into? This, I have to pay مثلا $2,000 or something like this. So am I really serious about doing this? Is this item really critical, and so on? So you have to do some thinking, and the firewall will not wait for you. It will kick you out, and the entire session will be done. So you have to go back from the beginning, select all the items again. So if you don't really design that workflow carefully, okay, by configuring the heartbeat protocol, then you might actually get the users really frustrated. And that's really what makes difference between one web server and another. These are details كده يعني that really developers, they need to pay attention to. So anyway, so the heartbeat is periodic signal. Periodic signal. And I have to make sure that this period is less than the time that the firewall will take to kick me out. So the firewall will invalidate مثلا the session after مثلا let's say 10 seconds. So I have to make the heartbeat period 5 seconds to make sure that the firewall will say, oh, okay, so this session is still valid. It will not kick me out. A heartbeat protocol is typically used to monitor the availability of the protocol entity, the entity on the other side. ماشي? It consists of 2 messages, the heartbeat request and the heartbeat response. It's very easy. I send you a message, I say, I'm alive. You send me a message, oh, okay, خلاص, I got it. You are still alive. And after some time, you send, I'm alive. I send you, okay, got it. Bas. Very simple. But this is required. Yeah. ماشي? So the purpose is to assume that the sender that the receiver is still communicating to is still alive, even though there may be no interaction between the client, no data interaction. ماشي? And it generates activities across the connection so that the firewall would not think that this session is invalid. ماشي كده؟ طيب. خلاص, we'll stop here. We have 2 slides to talk about قبل ما نخش في ال SSH. لا بس 2 سلايدز ممكن ياخدوا بتاع 10 دقايق، يستحسن